Today's lesson is going to be about areas of circles, sectors, and segments. We're talking about segments of a circle, not segments like you're used to thinking about segments in the past. Okay, so first of all, area of a circle. The area of a circle is pi times the square of the radius. Remember, the radius is from the center of the circle to a point on the circle. So for the first problem down here, I want to pay attention to the fact that it asks you to give your answer in terms of pi. Now that will also be an exact and simplified value. Remember that pi is irrational. So if you use something like 3.1 or 3.14 or 3.14159, however much you cut it off, you have rounded it because it goes on forever without repeating. So if I give an answer like 4 pi, everybody gets the same answer. There's no rounding involved, and it's the exact value. And then, of course, we're going to label. So we're doing areas here, so we want to make sure we label those correctly. Okay, so in the first problem here, that's the diameter because of where it's placed. If I wanted to show you the radius, it would have been written over here instead. Okay, so that's the diameter. So if the diameter is 20, that means that the radius is 10. And area is pi times r squared. So pi times 10 squared or 100 pi. That is an exact value, and then that'll be in meters squared. Okay, the second one, the radius is 25. So the area is going to be, I'm sorry, the radius is 5. So the area is going to be pi r squared or 25 pi, and that would again be in inches squared. Okay, find the indicated measure rounded to the nearest tenth. So the area of a circle is 153.9, and we're looking for the diameter. So since area is pi r squared, I'm just going to go ahead and find the radius and then use that to get the diameter. So I'm just going to plug into area equals pi r squared. The area is 153.9 equals pi r squared. So I'm going to divide both sides by pi, and then I'll square root the answer. So let me go ahead and do that. 153.9 divided by, there is a pi button on a scientific calculator. You probably have seen it before. On a graphing calculator, it is second function, the orange button, and then the little caret key that's directly above the blue operation buttons on the right middle side of the buttons. It's the little upward arrow key. So second function and that little upward arrow key is the pi button. Okay, and then I'm going to square root that answer. So to make it more exact, I'm going to go ahead and leave it in the calculator like that and then do the square root, second function, square root of the answer, which is second function, the negative button. Okay, and then rounding that to the nearest tenth, it's 6.9991 blah, 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 blah. So that means that the radius is approximately 7. Okay, rounded to the nearest tenth, the radius is approximately 7.0 centimeters, and that means that the diameter is double that, so 14.0 centimeters. Okay, find the radius of a circle with an area of 63.6 square feet. So 63.6 is area is pi r squared. So divide both sides by pi. And then we're going to square root both sides. That would cancel there. Okay, so typing into the calculator would be the second function square root of 63.6 divided by pi, second function caret key. You want to make sure that the whole entire thing is underneath the radical sign. So that's why sometimes I'll just do 63.6 divided by pi and then hit equals, then do this square root of the answer. Round it to the nearest tenth. R is approximately 4.5, and that was in feet, because the area was in feet squared. Okay, those are the super simple problems like we have you've already done in the past, I'm sure. Okay, over here, I probably should have shown this. We're square rooting on both sides after we divide out the pi. Okay, what's going to be new here is what's called a sector. So a sector is simply a segment of a circle that is formed by two radii. So radius, radius, and then an arc of the circle. So it's that thing that looks like a slice of a round pizza or a piece of a round pie. Okay, when you name the sector, you name it by the central angle. So RPS. If we write angle in front, then we're talking about the angle. If we write sector in front, we're talking about this region, that whole entire part right there. Okay, that's called a sector. A region bounded by an arc of the circle and two radii to the arc's endpoints. Okay, radius, radius, arc. Now, if we want to find the area of that sector, so let's think about a very simple kind of situation. Let's say that we have a circle and we know that the area of the circle is 16 pi. I'm not going to worry about units. Okay, just 16 pi. If I were to draw in a radius there, and then let's say a radius like this, where it creates a right angle, and I wanted you to find this sector's area, what would that area be? Well, it's a quarter of the circle. How do we know it's a quarter of the circle? Because 360 divided by the central angle of 90, I guess I should go the other way around. 90 3/60ths is 1/4 of the circle. Okay, so the area that is shaded there is 1/4 of the 16 pi. So if you do 1/4 of 16 pi, you're going to get 4 pi. Okay, what if we had a central angle measure being like this here? Let's say that that's 120 degrees. Well, 120 is what fraction of the circle? So now I'd be looking for this shaded sector area. Okay, and that would be, whoa, sorry about that. That would be 120 3/60ths, or 1/3 of the circle. And that means that it would be 1/3 of 16 pi, or 16 pi over 3. Pi acts kind of like radicals in terms of you can write it as 16/3 pi. I really would not combine a mixed number with a pi, but these two are really the same thing. You'll probably see me write it this way more frequently, but either of them is okay. All right, so that's the basic idea of how you do sector areas. So as a formula, the area of a sector is equal to whatever fraction of the circle that you have. And you determine that by figuring out what is the central angle measure and then dividing that out of 360. Okay, that's giving you the fraction of the circle. Let me just do this. Central angle measure divided by 360, and then multiply that by the circle's area. So the measure of the central angle in that picture would be the measure of angle AOB divided by 360 times, and our radius there is r, so times pi r squared. Okay, so you just think of it like central angle out of 360 is just literally the fraction of the circle and then multiply by the area of the whole entire circle. So even though that's a formula, it really should just make sense to you. Okay, so for problems A and B, we're going to leave our answer in terms of pi, and then for C, we're going to round. So just pay attention to what the directions tell you. Okay, the area of the sector. Remember that the measure of an arc is the same as its central angle measure. So that's a 72-degree angle. So the area of the sector is going to be 72 72 3/60ths of the area of the circle, which is pi times 15 squared. All right, 360 divided by 72 is 5. So that's 1/5 times pi times 225. 225 divided by 5 is 45. So that's going to be 45 pi. That's an exact value, and that's in centimeters squared. Okay, so basically the area of the circle would be 225 pi, and then we have 1/5 of that because 72 out of 360 is 1/5, and that means that our final answer will be 45 pi centimeters squared. Okay, a circle has a radius of 4 inches. What's the area of a sector created by a 45-degree central angle? Area of a sector is the central angle divided by 360 times pi r squared. Central angle is 45 3/60ths is the fraction of the circle. The radius is 4, so pi times 4 squared. 45 out of 360 is 1/8, I think. And so, yeah, that's 1/8 times pi times 16. So that would be 2 pi, and that's going to be in inches squared. Okay, the area of the shaded sector. Even though it looks kind of weird, this gray area is a sector. So all the way around there is considered a central angle. So just think of it like you have a pie and you eat everything but one tiny little sliver. So you have eaten all of this, but you left that tiny little piece for your sibling or your mom or dad or somebody that you're irritated with. So even though it looks kind of strange because that angle measures over 180, you can just literally do this central angle measure and then do the same formula. So this one I told you to round to the tenths. So we're just going to go ahead and plug in the calculators, what that means. Okay, so if that's 20 degrees, that means that this will be 340, 360 minus 20. Okay, so the sector area will be 20 3/60ths times, wrong. The area of the sector will be 340 3/60ths of pi times the radius squared, or 49 pi. Now, you can just literally type in the calculators 340 over 360, but just because there's a factor of 10 there, I'm going to go ahead and divide that out. Now, anytime that you're using pi on these problems, I want you to use the pi button. Don't use a 3.14 or some 3.141, whatever. Use the pi button because then we'll all get the same value rounded, and there's not the same rounding error between our answers. So 34 divided by 36 equals, then I'm going to multiply by the pi button, second function caret on a graphing calculator. Okay, and then I'm going to multiply that by 49. And I'm getting about 145 point, did it say tenths? Yeah, 145.4. Now this is rounded, so I'm going to say 145.4, and that's going to be in meters squared because we're doing an area. Okay, that's sector. When you think sector, you think piece of pie. Pie as in PIE. Okay, so this is like a slice of pizza or a cherry pie. Okay, the last idea here is what's called a segment of a circle. And a segment of a circle is formed by Let's say a part of a circle bounded by an arc and the segment joining its endpoints. Basically, think of it like a chord is going to cut off a segment of the circle. So remember, a chord is a segment that joins two points that lie on the circle. So a segment is formed by a chord and an arc in that little region in between them. Okay, chord and arc, and then everything that's between them is called a segment of a circle. So it's kind of like a little slice. You take a chord and slice off a little chunk of it. So when we want to figure out um, the area of a segment, what we're going to do is sort of think of it as a sector that we've removed a triangle from. So if we're trying to find this area over here, okay, we're going to figure out what the area of the sector is. So basically drawing a central angle here and turn that into a sector, this whole thing. Okay, so we're going to take this sector, we're going to subtract off this triangle, and that'll leave us with the part that we're trying to find the area of. So the area of the segment equals sector minus triangle. So if I have this part here, okay, and then that whole area, I calculated that. Move that over here. Okay, and then if I take off the triangle, so if I remove the triangle here, what I'll have left is this part. Ooh, that was terrible. This part. Okay, and then that will be matching up with the sector that we were trying to figure out. Sorry, not sector, the segment we were trying to figure out. Okay, so that would be what's left over. Okay, so don't overthink that. Hopefully that makes sense. You're just removing a triangle from, again, like right here, you're just removing a triangle from this the sector to get the segment. Take that out, leave that, and you got your segment. Okay, what's the area of the shaded segment in each diagram? Express your answer exact and simplified. So exact and simplified means radicals. Exact and simplified means fractions, no rounding, like 1/3 has to be a third, not 0.3. Okay, and also leave pi in your answers. So exact and simplified means no rounding. Okay, so the area of the segment is going to be the area of the whole sector minus the area of the triangle. Okay, so let's figure out the sector's area. So area of the sector, and we're talking about this sector here. Okay, so the area of the sector is going to be fraction of the circle, so it's 63/60ths times pi times the radius squared, pi times 18 squared. Okay, that's 1/6 of pi, and then 18 squared is 324. 324 divided by 6 is 54. So that's exactly 54 pi. Okay, so that is the sector area. Of course, that's in inches squared. Okay, the area of the triangle. Okay, so the fun thing about this is we get to use what we know from earlier in this chapter with the regular polygons. So notice that this is a regular triangle because those are radii, and that's going to make those 60 degrees. So that's a regular triangle with a side length of 18. So I'm just going to do the s squared root 3 over 4 formula. So 18 squared root 3 over 4. And 18 squared again, so 324 root 3 over 4. And that'll go in, that's 81. 324 divided by 4. Root 3, again, that would be in inches squared as well. Okay, so I'm going to remove that triangle. Okay, so we have the whole sector's area. So if we do the whole sector's area, and then we take away this triangle here. So we're removing this triangle. What we have left is the segment there that we were trying to find. Okay, so we're going to subtract those answers now. So the sector minus the triangle will give us our segment area. Area of the sector was 54 pi. Yuck, that was awful. 54 pi. And the area of the triangle is 81 root 3. Your answer's in inches squared. We really can't do anything else to that. It seems unsimplified, but that's it. You're going to get lots of weird looking answers on these problems. That's kind of good because you kind of know it's supposed to come out to look weird. So sometimes it might not look as weird as that, but a lot of times you'll have radicals in there because of the equilateral triangles or 30, 60, 90 triangles or 45, 45, 90 triangles. And then you'll have the pi because of the area of the circle that's being used. Okay, so again, the area of the segment, which is the little slice of the circle, is equal to the area of the circle. I keep trying to say that. Area of the sector minus the area of the triangle. Okay, so the area of the sector, and that's the slice of pizza. Okay, the sector will be 90 3/60ths, or we can just think that's 1/4 of the circle, times pi times the radius squared is 16 pi. So 1/4 of pi times 16 is 4 pi. That would be in meters squared. Okay, and then our triangle area, this one is nice because that is literally a right triangle, so I can just do the 1/2 base height situation. So 1/2, the base and the height are perpendicular, so it's 1/2 of 16, which is 8. And that's our triangle that we're subtracting off. Again, that would be in meters squared. Okay, so the area of the segment is 4 pi minus 8 meters squared. Again, a lot of times these problems will look kind of funky. These answers will look funky. Okay, and then the last one, I said in the problem, I said the shaded segment, but then I added that problem on the end. So technically you're not finding a segment here. We're just looking for the shaded area. Okay, so sometimes students look at this and think, okay, I'm going to find the area of the segment and then subtract that off from the circle. And that will give me the white, um, that'll give me the darkened part. So I'm just going to take the white part away from the circle. The thing is that finding the sector is a little bit more complicated than if we just think about adding. So on this problem, we're going to just do, sorry about that. On this problem, we're going to just do the area of the triangle plus the area of the sector, which is the big gray sector. That's going to give us our shaded area. All right, so the area of the triangle, again, that's a right triangle. So area of the triangle, I can just do 1/2. The base and the height are perpendicular, so half of 144 is 72. That would be in centimeters squared. Well, that's our first area. Okay, the area of the sector is 3/4 of the circle, right? Because if that's 90, you're not using a quarter of it. That means this is 270 degrees. If you take away the 90, 270, 360. So you don't have to do it this way. You can look at that and just say that's 3/4 of the circle times pi times the radius squared, which is 12 squared. Okay, that was 3/4 of the circle times pi times 144. So 144 times 3 and divided by 4 is 108, exactly 108 pi centimeters squared. And then our final answer, our shaded area, will be the area of the triangle, which is 72, plus the area of the sector, which is 108 pi. And that's in centimeters squared. Now, again, you cannot add those together because those are not like terms. So if it was 72 pi, that could add with 108 pi. But you cannot add a pi with a non-pi value. So the pi and the radicals are not like, the pi and an integer is not like, and so that'd be your final answer. That's the end of this lesson.